Hey, you guys, how you doing today? Today I'm gonna go back here to the CNC and show you guys a few things. So yeah, we're gonna kind of go over tiling today, and then we'll get into a few other things. I got some projects to show you guys as well, if you are interested in seeing those. That camera, yeah. Uh, and I did end up hooking up that. If you guys saw the community post, I posted about another camera that I got. Hooked up that one. I don't know which one I like better. This one here, we'll call this camera number 1, or camera number 2. That one over there. Which one do you guys think? I know the color tone's a little bit different. I gotta correct for that a little bit, but we'll see. And let me know if you can hear me or not, because I am talking. Anyway. I guess I could put that on the video screen itself, which camera I was talking about. But anyway, we're going to go into tiling real quick. I've got a project set up over here, an easel that I can show you, and we can jump into that. Let me double check that this is working today. Oh, it does work. All right, cool. Who else here? Anybody that has been here before that I know that we've kind of talked in the chat, or if you're new, let me know as well who you are real quick. And then we'll jump right over it there and get started. All right, so I have over here on the a project that's set up for tiling. I use the X-Carve work area here of 39 inches. Yeah, 39 by 39. And we have a board that is 47 inches long. So it's too long to carve in a single job. So it defaults to tiling is turned on over here. If you can see this, tiling is turned on by default. And so far we've got 2 tiles set up. And again, by default, they set up to overlap. I don't think you can actually turn this off with V-bits. Let me check. Yeah, it doesn't let you turn it off when you've got a V-bit selected. Because in order to avoid like a step there, it requires overlapping a little bit. So I don't really love overlapping in the middle of a letter, but for the purpose of this, I do want to show you like some tricks over there on the CNC, and we'll go through some things that will really help, even if you do have to do the overlapping. Like there's a Carve and Create video that came out where they carve a huge, they cut out a huge piece. So there's no avoiding the design going through the entire tile. There are ways to take this welcome sign and set it up so that the lines are kind of in between the different letters. If you adjust the tile distance here, we can squeeze out a third tile, change the distance. So we put one right at 20. And that kind of puts the line right in between that. And then we come over here to the second one, and actually 20 is not good enough. It needs to be, I think, 21. So if we squeeze it right inside that, see there, then we come over to the next one, see how it misses the O. We just need to miss the L here. 14 point something. 14.2 misses the E, and then our final tile is going to just barely miss the bottom of that L. So that is one way to kind of get around this, is to make it so that your tiles miss the next letter. So when we simulate this out, you'll see the toolpath doesn't bother going up to carve the next letter, so you don't end up with any split letters in between there. And that really does help with ensuring you don't get weird tool marks that are misaligned. Even if the letters are slightly misaligned going up, it's going to be so difficult to notice that. Thanks, Brad. Thanks for letting me know that you guys can actually hear me. That's good. Hey, Doug, what's going on? How's life? Let's jump back over here real fast. been working on AI to run your Queen AI. Hopefully, we'll see. Like full AI, is it going to write the G code for you too? I heard that Titans of CNC ran or was trying out some Chat GPT generated G code by teaching it G code and then telling it what it wanted created. It wasn't the best results, but the machine moves, so. I mean, hopefully your computer doesn't freeze up. Hopefully, now that I'm on my desktop now, so I don't think I have to worry about the battery dying anymore. So, yeah. I'm going to switch back over here to this, and we'll jump back where I was. So I split up the tiles here a second ago so that the carves are on their own individual tile. We don't have like a split letter. Now, the reason I would prefer to do that is so that you can avoid having that scenario where the carve is going straight through a letter, because then as you slide the tile to the next position, when you slide that tile up, it can cause the carves to basically, you got, how do I do this? So you got the let's say if this is like the O in that word welcome, the two different pieces. If you slide it up and your edge piece is not straight, then the two pieces will be offset like that, right? So instead of aligning perfectly to make the O shape, you'll have them slightly offset like this. If any of you have tried tiling, there's a good chance that you ended up with that problem. And then also how they're supposed to, one, they're not going to align properly, but then also they can be the wrong height, like either gapped up too far or brought way down too far, and then stuff doesn't align in both axes. So I can jump over there to the CNC and I'll show you what I do to have that sidebar be perfectly aligned. Now you can see that my wasteboard over there is really carved up and pretty tore up, right? Let me see if I can find the other view here. There we go. Hold on. Let me take care of that real quick. That works a lot better. All right. So I can move this away, actually. My Z-Probe actually plugs in to the middle of my gantry back there, and with a quick barrel connector, so I can just unplug it really easily like that. And then the reason I have a calipers up there still. Where's that board? So this is a piece of plywood, but ideally I would take a piece of MDF and clamp it over here to the side as far as possible, but I don't know how I can see that in the video. So we'll pretend this is the side of my CNC here. And clamp it down, or in my case, since I do a lot of wood screws right into the MDF, I would put a couple of screws in here, like 3 or 4. And the longer this side piece can be, if it's the full length of your work area, that way you can cut so the idea is that you take the CNC with an end mill in it, and you come back and you cut a clean face on it after this is like bolted down or very well secured in place with clamps, right? Because then this isn't going to move. And once you cut that clean face to it, then it's going to be perfectly in line with your y-axis here. Not sure how that video is. I think it might be glitching a little bit. Yeah, so with that, let me see if I can do this real quick. And yeah, so the idea is that that side board would go the distance of your work area, kind of like this, right? And we cut this face here using an end mill, right? So you clamp down a piece of preferably MDF, and then you would do another design where you're just doing a straight line cut, and right on the 0 line there, straight up the edge. And you'd place your X and Y zeros right there, a little bit inward from the edge of the board. That way you're cutting a clean face front to back. And you would slice a clean face on that board there. And what that's going to do is make sure that that edge that new edge there, that blue one, is perfectly parallel to the y-axis, you know? Well, that yellow one's kind of hard to see, isn't it? Anyway. So it basically makes that new, the new face that you just cut along the edge of the board is perfectly in line with the y-axis because you cut a straight line in line with the y-axis. So then when you do slide this down, now it's going to slide down perfectly in line. Now there are some other videos out there that show like butting bump stops up to the edge of your board. That is effective if you can get all of the bump stops perfectly in line with the y-axis. And there are ways to do that by using the bit and bringing the bit over and then just jogging it forward and using the bit itself to align those two. But if you're doing this, then each of those little pieces that you got there would have to be like, this is my bump stop, and then I've got another bump stop down here and another one right here, right? If I do that, these are made easily crooked. So if they're not quite in line properly and they're slightly out of crooked there, and the next one is as well, and the next one is as well, then you've got this continuous angle going on, right? So you really don't want that, right? So by cutting that clean face on it, we kind of take care of that problem. I'll jump back to you in a second, Southern Joe, but yeah, so that's the whole idea with that edge there. And then the other thing that how loud is that? That's probably pretty loud too. Anyway, the other thing that I like to do is, once we've got that board set up, right? We can come over here and instead of using the very, very edge of the board, right? I would prefer to have the board come a little bit further, not extending past where the CNC can reach, because the CNC has to be able to reach that whole entire front, right? In order to cut that line. And then we can come over here and use a V-bit to mark exactly where the zero plane is across the Y movement, right? And so then when it comes time to slide our workpiece, we can look at the tiling amount and we know exactly how much to slide it. I would come up and, so I'm sorry, we would mark the zero plane here, right, with the V-bit. And then we come up here and jog the CNC up a specific amount and mark another line right there, right? Using the V-bit as well. And if we've got different tile lengths, we could mark additional locations. So we know that this one is 16 inches, right? And this one is 17. And this one is like 18.5. Whatever the different tile movements are. You could label them with just drawing on your board with a pencil, but if you mark the actual zero and the different distances to slide directly onto this board, you could then take a piece of blue tape and place it like that, all right? Or directly on this board over here, so that you're transferring the mark over to that board. So for this one here, we'd do it like that, right? And then you slide it down so that mark that you transferred over equals exactly where that 0 point is. And the reason why I would do this is because what are the odds that your CNC is perfectly calibrated? And so is the tape measure that you're using to measure this. If they don't match each other perfectly, then your tiling is not going to match up right. So that's why I prefer to use the CNC to do the actual measuring by jogging it up there and kind of marking that board itself, if that makes sense. And then it doesn't really matter if your design is such that you can't avoid the design being overlapping the edge, right? So this one here, like I said, I went ahead and adjusted the tiling to make sure that it doesn't overlap itself at all. But if you can't avoid that, then that's another, great alternative, right? Is that measuring using the CNC itself. Does that make sense to you guys? I mean, the dog hole type of spoiler board will work as well. It's just that you're putting but also, the dog holes could wear out because you're putting them in MDF here. It's not like you're putting them in hardwood like you might for a pretty strong workbench. You're putting them in an MDF surface, right? So they could stretch out the holes over time, depending on how aggressive you are with the dogs. If you're using cam clamps to hold your workpiece against the edge. And again, I like to secure my workpiece with downward pressure, not just edge cam clamps like that, right? So you guys can't see what I'm pointing at either, but yeah. Ooh, I bet you can if I do it differently. Anyway. Oh, that's cool. Yeah, so as long as you do that sort of, the dog holes do work well. If you haven't watched or seen yet, check out another YouTube channel called Bro and Wood, and they do some amazing inlays, right? And he uses kind of like dog holes. He's got holes milled out that perfectly fit some, I think it's like Schedule 80 PVC piping, right? And he uses that for his edge alignment, kind of the same way that I've got that board set up over there, right? But your dog holes would have, they obviously have to be tight fitting to your PVC or whatever you use in the dog holes. Obviously PVC is pretty cheap and easily to cut down to various heights, right? You're going to have to ensure that those are perfectly aligned when you carve it, and that the holes are not blown out, or if they do wear and become like oblong or oversized for the PVC, like it's not a super tight fit, then that's obviously not the best scenario there for you, right? But there's nothing wrong with trying it, and if it doesn't work out, you could just not use those dog holes. As you can see how tore up my wasteboard here is in this video, and I'm not sure if you can see the holes in there, but there's a bunch of screw holes in that wasteboard. It's a lot of times I will just screw directly to my workpiece. I have a little bit set down here that I always use with the CNC, and in there we've got just some cheap and some broken smaller ones, drill bits, and then a bunch of countersinks that I use to countersink right through the material, and then I screw right into the board with wood screws. And there are some hiding here on the wasteboard, but there's also a bin of them down there in organized pockets in various sizes. Down below somewhere. And then I'll just pull out the right size wood screw for what material I'm using, whether it's 3/4, half-inch, or 1/4-inch material, and then I'll just screw directly into the wasteboard. So if the dog hole didn't work out for you, you could just do that and try to avoid where the dog holes are when screwing into the wasteboard. And then you wouldn't have totally wasted the MDF on drilling dog holes that didn't work, if they end up not working. But they probably will work for quite a while until the holes could become, oversized or blown out. Hey guys, there's quite a few here. Hopefully you can hear me when I'm over there at the CNC. I didn't look at the volume level when I was over there. Anyway, yeah. So what'd you say, Jeff? I just did a long straight edge as a bump stop and put a mark at starting point and penciled every tile dimension down the line. So if you pencil the the only concern really, Jeff, is that your like I said, the reason why I would jog it and use a bit itself to mark it is just to be sure that if the CNC is off by 0.5%, you're going to have a variance between that and your tape measure. especially if you got tape measures from like Harbor Freight. Or I saw somebody, I'm not sure if anybody else saw that earlier this week, but there was a posting and the person was using a like a seamstress style tape measure roll, like the cloth ones, to measure the workpiece and saying that it was out of spec. And that is not quite the best, most accurate way to measure your cutout wood piece. If you use that exact same tape measure to do your calibration, and you burned the first inch on the tape measure, if you guys don't know what that means, I guess I could show you what burning an inch means on the tape measure with one of those lovely cheap Harbor Freight ones. But so hopefully you guys know what it means to burn an inch on a tape measure. So because of the way that this front piece moves, and many tape measures, it's supposed to move to account for the thickness of that piece of the edge there anyway. So it should only move the thickness of the edge. But a lot of them are too loose or wobble around, or some of you end up, I see people clamp them so they end up being, they increase the strength of the rivet so that they don't move around. And that's going to cause it to be accurate in one measurement, but not in the other measurement. So, so the idea here is that when you are trying to get super accurate, you do what's called burning an inch. So instead of lining this up to the edge of your workpiece, you actually feed it down to the 1 inch point. So you don't actually measure from. So I wouldn't actually measure this like that. Instead, I would slide it down to that 1 inch tick mark and then measure from there down to see exactly how much it is. So obviously it's not 2 3/4 inches. It's 1 3/4 inches. Got to subtract that one off that I burned to begin with. Whereas if I measure it this way, it could be about a 1/16 to 1/8 of an inch off because of the variance in that front edge piece. Higher quality tape measures, I don't quite have that big of a problem. But I've seen tape measures get tossed around at the store before you even buy them, so who knows sometimes, right? Are we on that camera? Oh man. I think I need to like color code the cameras now since they look almost identical. Anyway. Yeah. Those inlays are pretty neat, Craig, the way that he does them. There's a few other guys in some other groups that I'm in that are pretty good at them too. I think Bruin would. I forget the guy's name now. I want to say it's Ryan, but anyway, I think he does some good stuff in his videos where it's really difficult to see the imperfections. There are some that I've seen if you look close enough and pause the video in the right spot as he's right before or as he's oiling it, you can see that there are small gaps where wood pieces are broken out. But man, he does a great job of making it nearly disappear, right? And that's the hard part, is even when you do it all the time, there's still going to be small wood chip outs. And the thing that I haven't done one of those myself yet. It's the end grain for me, right? That's work to do a whole glue up that's end grain. That way you get the best strength in the fibers to really be able to do an inlay like that, right? And have minimal chip out. Yeah, so I can go over there real quick and show you what I mean with sliding this down that CNC, but I think you guys pretty much understand that already. So instead, we can just go through a couple of questions or some other stuff that I'm working on if you want to do that. Why did I click on that already? I can't read it. I can actually read your comment once I click on it. It like highlights it super neon green. I can't see it, but let me see. I'm getting ready to carve a flag. When tiling, is it best to do both the roughing pass and the detail pass before you move the board? Yes, you want to do both passes before you move the board. And that is because there's no way you're going to get it realigned to the exact same spot. Even using this method I'm talking about of marking it on the side and transferring over to the board, you're not going to be able to get it put back to do that initial or any previous tile position perfectly. And then it's going to show on the edges especially, right? So yeah, you want to do the roughing and then the V-bit and then move your tile and do the next roughing and V-bit. Now the thing is, you could look at what you could do to bring it down to just one bit. There are a few tricks over here. I'll show you that real quick that we can do here to make it carve a lot faster. So for instance here, if I'm going to carve this out of, I chose acrylic just because it shows up a lot better on this, on the preview over here on the right versus just the wood, where it's kind of hard to tell the difference in the two depths, right? But if you're going to be painting it anyway, you can kind of cheat the V-bit quite a bit, right? So the default, what happens here is Easel uses the width that you've got entered for your V-bit. And these ones here don't actually show you the width once you got them saved. But if you go over here to the toolbox, you can see we've got the V-bits, and they each have a width. Where's that at? Oh, I think I need to go that one. There we go. So we've got the V-bit here, and we've got it's calling it cut dimension now here, but that's the diameter of the cutting head of the V-bit. Oh, you guys can't see my screen. There we go. So yeah, this right here is the diameter of the cut. I went here, sorry, I'll go back real fast. I went to toolbox up here and I set it to detail view instead of this default one. You can see we've got cut dimension and angle. The end mills that are up here don't have any angles assigned to them. And then yeah, the V-bits that are down here, we've got an angle, let's say the 60 degree, and the 1/4 inch for the dimension. And that should be the width of the maximum width of the cutter head, right? I kind of went into that in a different live stream where we talked about how to enter these bits, but it then takes that width and multiplies that by this setting here, the V-bit detail step over, which by default is 1%. So if you're going to be painting this in, you can often cheat this to a higher number. So by changing this from 1% to 2%, that's actually going to cut down on your V-bit carve time by almost half. And if you bump it up again to 3%, it's going to drop down your carve time by a solid 2.5% for that V-bit. So oftentimes you can cheat and change this. Here, I'm gonna for the purpose here, I'm gonna go ahead and make this a 2-bit carve with an 1/8 inch and a 9-degree V-bit. So we've got 14 minutes to do this first tile with the 1/8 inch and 10 for the V-bit. Personally, that's already low enough. If my end mill is less than 30 minutes and my V-bit is also less than 30 minutes, I'm not going to put an end mill in because it's going to take me longer to switch it out than it will to do this carve. But if you want to cheat that even more, like I mentioned, you can come up here and change this 1% down to about 3. So I had a moment ago, I had 14 and 10, right? Let's get rid of the end mill now. I kind of wish there was a button right there to just get rid of the end mill, but there's not. So we kind of got to go through here and select my V-bit again. So by changing it from an end mill and a 90 to a 90 with a 3% step over, we went from 24 minutes and a tool change to 26 minutes. And if you're doing that with every single tile, that's more and more tool changes. How long does it take you to do the tool change, to probe Z again for that tool, for that second tool, to make sure your X and Y zeros are all lined up? For me, I would just increase that V-bit step over a little bit and run the V-bit only, especially if you're going to be painting it in. And if you're going to be staining it, going from 1% to about 2 to 3 is not going to be visible. Like, you're not going to be able to see the ridges that are going to form in there. Yeah, it is going to cause more of a step over, so you are going to have little peaks and valleys in here a little bit. And depending on what size they are, paint's going to fill them just fine, and you'll never even notice. Stain can fill them a bit as well, but it might be something you want to test before you go running the entire board that way, right? You can toss in a piece of scrap, do a couple of tests with different step over percentages, and then possibly stain it and see if there's a point where it reaches, oh, that looks like crap. Maybe I need to go and do like 1 or 2 steps down. Don't go to 9% with that V-bit setup. Go to a 5 or 6, you know? and it looks okay. And then you're able to cut so much time off that way, right? So personally, I've got this set up to do a 90-degree V-bit only, and I'm okay with what ends up being just about an hour and 15 minutes to carve all 3 tiles here on this one and have it split between 3 tiles, you know? All right. You know what I didn't do? Hold on just a second. Well, let me know if you guys have any other questions, because I know it takes a minute for the latency of the video to catch up and that sort of stuff. Oh, that doesn't work. I can't just keep scrolling my mouse over to a whole nother computer. Anyway, how are you guys doing? Do you have any projects this week besides tiling to work on? We can go through some other stuff too. I think I've covered just about everything I wanted to about the steps that I use for ensuring that the tile comes out well. Yeah, we could do I've got another project going on back here that I want to show you. It's pretty neat, but I might have to go through a whole step-by-step on how I made it at some point. Because the guy that I followed, man, I followed another tutorial for it, but he's from Sweden, and then he's following another guy from Sweden, speaking in Sweden, to do the version that he did. And then when I tried to follow his version, he skipped a bunch of steps. So then I had to go watch the video that's voiced in Swedish to figure out how he coded it to work, because the code on this device, I'll show you in a minute, didn't work right originally. So yeah. Anyway, when you see it, I think you'll think it's pretty neat. Even though, I mean, if you're not, yeah, there's store-bought ones that cost 10 times as much that do the same thing. But anyway. All right, we'll post that real quick. Perfect. All right, we'll jump back over here. Yeah, I mean, Troy, I appreciate you guys hanging out with me. You know, I like sharing anything I know with anybody who'll listen. Oh, that is really weird. This one over here is stuck. Oh no, there we go. All right. The preview that I had showing was like stuck on showing the wasteboard. Like, that's not what we're seeing right now. Anyway, so we can bring in another project here. I'm going to go ahead and bring up the well, I said I was going to show you guys real fast. Let me jump back in real quick. Oh, it's going to take a second to load, isn't it? Do this. That's okay. All right. Ooh, it's getting trippy now. I have to machine a piece of acrylic for the front because I cheated and I 3D printed this frame for it, but or the main housing here. Oh. But as this loads up, you can see it shows the view count and subscribers of the channel. It's just an LED panel wired to a little tiny Arduino Uno board, right? And with a little Wi-Fi adapter to it that's in the back here. And by linking it to the channel, it'll display the subscriber count, which I think is pretty neat. But anyway, neat little project. I'm going to have to use a CNC to machine a face for it out of acrylic. But yeah, that's what I'm going to cut later today on my CNC. Is the face for that out of some clear acrylic. The thing is so bright though that it kind of blinds the camera. So I will see if I can get some smoked acrylic to go over it to kind of tint that. Actually, I might have some window tint material I can use for it on the face of the acrylic. Anyway, we can jump back over there. Could you see it, Doug, at the end there? Hopefully you could. Anyway, it's just 4 LED panels. I think the panels cost like $10, and then the little Arduino board that goes inside with the Wi-Fi chip in it was like $6. And then the 3D printed housing was about $2. So all in, I'm in like maybe $18 to make the panel, plus some leftover acrylic from a different project. And you can make it say different things, connect to different. It can connect to your TikTok, Instagram, YouTube. The tricky part is the code that one needs, right? They do sell those same sort of devices that are manufactured that you just kind of log into your. It's has a lot better interface, and they cost like $150 for a large one, and one about that small still costs about $80, right? So I made that one for about 18. So it was a fun little project, if anything else. Yeah. Oh, let me jump back over here. I said we are going to do something else, right? So originally I kind of came up with that idea of the side panel after watching a few other things that has to do with doweling, right? So depending on what you're carving, you could also use dowels down the side of your actual workpiece and use the dowels for indexing, and then use like an oversized workpiece and then slice down that edge with the dowels using like a table saw at the end. And that would allow you to index using dowels, which the dowel indexing thing works really well with doing multi-sided carves, like a top and a bottom where you've got to flip it over. The dowels work really well for that. And they can work for this as well. There's a guy who did a super huge sign for his neighbor, like a neighborhood sign. It's like 8 feet by, yeah, it's about 8 feet by 16 feet long that he did. The thing is huge, but the CNC that he did it on was only 8 by 8, right? So it barely fit, and he had to do, I think, 3 different tiles to make it work on his machine. So it must have been longer than 16. But anyway, he used these dowels on the bottom portion of it, and then slid that down the table saw to cut off the dowels afterwards. And that's a pretty neat trick as well, right? Yeah, you're good, man. Yeah, so I think that's about everything I want to talk to you guys about this week. I'm working on a few other topics for next week, and hopefully editing the video on how to set up that game controller is more of a tutorial step that we did last week, because sometimes the live streams do get off topic with me answering you guys' the comments that come in, right? Which I love. It's all fun, you know. But yeah, we can go over. I guess we don't need to, but if you guys don't have anything else to go over, I guess I'm gonna just call it a day right now, right? Unless you want to carve a piece of acrylic with me while on the stream, which is probably pretty boring. Anyway, I didn't plan for this topic to end so quickly, but I hope you guys have a good weekend. I am going to jump out of here. If you guys have anything you want to chat with me about, most of you know how to get a hold of me through Facebook and a DM, and I already heard like a handful of messages coming through. So there's a few people that are asking for help anyway. So you guys have a great weekend. If you guys have any projects you do want me to cover in these, you know, my email address is cncseth@gmail.com, and you can send me the projects, links to your easel or Carveco or VCarve, Aspire, whatever projects, and we can go through those as well. And if you haven't tried already and you want to try Carveco, because it's a little bit more in-depth software to use than easel without some of the problems that easel has, there's a link for that down in the description of this video. Oh, let's do one more thing real quick. I just set up this brand new computer that I have right now to be able to do these live streams on and to edit video on, right? So before I do let you guys go, I want to show you one more thing real fast. I'm just going to go ahead in the projects here and open a slightly complex 3D design. That way I can steal this, and I'm going to also open it in Firefox. Okay. Hopefully you guys can see that. All right, so I've gone ahead and set finishing bit at 0.05 inches, and I'm just going to run the generate toolpaths here once I do one more thing. Does that button work on my keypad? It does, okay. All right, here it shows what our memory usage is in Chrome. We're at 2.5 gigs of memory. That's running right there in Chrome. And if I click generate toolpaths, continue anyway, we're going to pull this up and see how high this goes. We can look at this one as well. But Google Chrome itself, right? We're at, hitting 5.5, 6 gigs. It jumps right back down to, it usually stabilizes at about 5. I'm not quite sure why we're seeing 6 there. It could be because I've also got another window open with the live stream going, which was this second one here. So for the main one that we're running the toolpath in, we're only at 3.6 gigs, 4.4 gigs, about 4.4 gigs, right? Is what it maxes out at for RAM usage, right? Joe, I actually, yeah, we can go with that real quick, but I actually built the computer myself by sourcing a bunch of parts off of Amazon, primarily. There's a few things I had to buy off Amazon to get the parts I wanted. In time, actually, I think, did everything come off Amazon? I might have bought only like 1 or 2 components off of Newegg, but I want to say that everything came off Amazon. But it was about $2,000. But it's a pretty hefty computer with high-end GPU as well, because I want to be able to run multiple monitors. Right now I'm running 2 with the capacity of, like, off the GPU I can run 4. And even then, okay, we failed out, and the most we hit was 4.4, right? If we jump over here into Firefox and run that same carve real quick, just to get a comparison data of what Firefox does versus Google Chrome. And I'll show you what settings we set in Firefox to achieve this sort of a level. Yeah, generate toolpaths, everything's the same, right? So before we were maxing out Google Chrome at what, 4.4 is our top end. I was seeing numbers like 7 gigs earlier in Firefox. When I ran this test, we'll see if we'll get there again today. Having the live stream running probably isn't helping it because it's running through Chrome in the background too. And this screen recording software that I use. Ooh, so we're not quite even hitting that same numbers I was hitting earlier on Firefox, but usually it does. We'll see what happens here. So the reason why I'm suggesting that you guys do this is because Google Chrome doesn't, the way that it works, it kind of, they did some updates recently that help it out, but in the past it would run all every tab that's open, and it keeps them updated and live, which uses RAM for these other tabs. It also has a limitation on how much RAM it would bother pulling. So even if it's trying to do a function that needs more RAM, it wouldn't pull more. Whereas Firefox can do that if you go and activate a few settings. So this one here, we're just about the same amount, but I think it's going to error out anyway. I had some other settings earlier. I used an even smaller bit, and I was running like 7 gigs in Firefox, and Chrome was topping out at about 4. But anyway, if you do want to use Firefox to get a little bit more out of your computer, you can come over here into settings, and then we scroll down to this one about performance. And by default, this box is checked that says use recommended performance settings. And then this one doesn't apply when that one's checked. So if you uncheck that and make sure that this one here is checked, that's going to give you the best output out of Firefox. And if you're not aware of this, Chrome is the source code that Edge also operates on. So and you guys can't see anything that I was just trying to show you. That's pretty funny. Not really, but sorry, let me show you that again real fast. But yeah. All right. So that one aired out too, or that's the previous one that aired out. But anyway, I'll pull those up again one more time real quick and show you. But between Firefox and Google Chrome, Chrome has the ability to pull more RAM. Now I noticed that it is using a little more CPU. Sometimes we do have these that try and run it in efficiency mode. You can come over here and turn off efficiency mode, and that allows it to use more of your CPU and memory. So sorry, let me run this one more time so we can get a comparison data real quick. So right now it's running Google Chrome one, and we'll see what that one tops out at one more time, with you guys actually seeing the screen this time. Yeah, we can go into what I'm using here. Let me pull that one up too for you. So this one here running in the background, we've got Google Chrome that hits 3.6 on this tab. It should be about 4, topping out at 4. Or 4.2 gigs, just about right. And then we run the same thing over in Firefox. It does take, has the ability to use even more RAM. You know what? I just pulled up the wrong account too. That's funny. Yeah, so some of these we hit 4.7, but that's a quick 4.8, and then it will drop out, right? Back down to 4.4 is our running. Oh, we hit 5, and then it pulls too much RAM, and then it crashes out in Google Chrome. Don't know why, but if we jump back over here to Firefox and now run that one again, I'm going to close that tab and do it again. If you have your main one here running in efficiency mode, I would turn that back off. I think there's a way to permanently turn off efficiency mode for Firefox, but because my laptop doesn't do that. We'll see how much Firefox pulls now, right? So we had it topping out at about 6 over on Google Chrome at the very max, but it was averaging about 4, 4.2. So for a GPU on mine, Joe, I use the Radeon RX 7900 XT. GPU. I actually used it's like a kind of like a souped up version, whatever, from XFX, which is not. It's there are other versions that are better, but for the price, this one was like cheaper than the stock one, and comes with the larger coolers on it, a bigger heatsink mounted to it from XFX, and at the click of a button on the side, it goes into their overclock settings just by pressing one little button on the side, right? Which you think, oh, you're never going to go inside your computer to do that. But let me go grab something real quick here. All right, steal that other camera real quick. All right, let me see if I can pull this really quickly here. Oh, there we go. But I actually 3D printed the frame that mine's mounted to. Oh, if I can stabilize this well enough to see. So the GPU is all out there and exposed because it's a 3D printed open frame design. So I 3D printed that frame itself there. Hope you like my power cords hanging back. And yeah, it's all pretty exposed, right? The water, we got some water cooling going in there for the CPU. Nothing too crazy. But yeah, it works out really well, and it's super quiet for the live streams, you know. The big thing was I was running out of 3.0 USB ports using my laptop, and even using a externally powered USB hub for certain things. The laptop that I had tops out at 100 megabits per second Ethernet connection, so I was actually getting faster speeds by using a USB adapter for Ethernet to be able to get faster Ethernet speeds. And now with this new computer, we're even faster than that. So anyway, I guess I'm done running this test over here. The moral of the story is Chrome is getting better, but the settings inside of Firefox, if you turn on that advanced hardware mode, allow it to calculate longer without crashing, because it's not going to crash. It's going to keep on trying to calculate. There is a point where Easel will not allow it to make a toolpath file so large, and it'll just sit here forever on Firefox, whereas in Chrome it'll crash. But I have been able to run some in Firefox that would crash in Chrome because of those ability to change the settings. Now, like I said, Chrome recently did an update where they are getting better at how they allocate the RAM, but from what I've seen, Firefox still works a little bit better. And if you want to see one thing just for fun, on this computer, you can see that the network speed is a little bit better than what my laptop was. Anyways, I think most of you have already tagged out for today, so I'm going to do the same here shortly. All right, so yeah, you can see the speed on this new computer is pretty, you know, it's nice. Anyway, that's what happens when you live in a place that has fiber optic directly to your house, right? Yeah, so the no freeze frames, I still haven't even bothered updating my streaming software, because I can obviously push it a lot more than I was in the other computer. That was giving me a little bit of latency on the other computer sometimes and freezing occasionally. But yeah, the other new camera that I got, it actually runs 4K 60 frames per second. And yeah, I haven't even had a chance to really try that too much. This camera here is the new camera, which I'm not loving the color on just yet. I might be able to tune that a little bit better. And then this one is the 1080p camera from Elgato. It's a face cam. Both of them are great cameras for streaming. The other one is the Facecam Pro from Elgato, and it runs up to 4K, 60 frames per second. Excellent camera. Which I'm going to have to mount one of these to the CNC and record it running over there. We'll see. Or I guess I could show you the mount that I made for attaching my phone directly to it. But with a second older phone that I'm not actually using, that's not on data anymore, that's what I typically record on the CNC itself. That way, in case it would ever fall out of the mount and get chewed up by the CNC, at least it's not a phone that I'm actively using right now, right? So this camera right here is the old one. Is that one more clear? Or is the one that kind of makes me look a little sunburnt or pink more clear? I don't know. This one here is actually a 4K camera. I'm not streaming in 4K, so both are about the same anyway. But that new camera has a super wide view, a better aspect ratio, more. You can actually, I can actually have it zoom in on me and then track me around within the zoom view. It's pretty neat. You know, now that I'm seeing it on, I think it's the monitors that I got for this new computer that I need to change the color tone on, because I also have my laptop going and showing the live stream. And you're right, the color doesn't look too bad. Anyway, you guys, it's been cool hanging out with you today, talking about computers and stuff too. Southern Joe, I could give you the whole list of what I bought for this computer, or I could just post it all up on another blog post. But yeah, it was about $2,000, and I kind of cheaped out on 3D printing the frame, which took about a roll and a half of filament. And I just used old filaments that I didn't really love the color of or the quality that was coming out with them, because I don't really need a super high quality frame anyway. And there's a few areas where I actually ended up hitting the end of the roll and I spliced on a different color. So it was really just maximizing the product that I had. And then what's neat enough is with the 3D printer frame, it doesn't fit that GPU. The GPU is too long. But I just took a flush trim saw to it and hacked off the bottom, the corner that was hitting the GPU. And it fits perfectly, and it kind of works like a little, like some of the GPUs that have that like rod that comes down to hold its own weight up. The frame kind of already does that by the way that I cut it. It supports the GPU. Yeah, I've been messing with the color of both of these cameras, but I don't. We'll see. We'll see. Yeah, we should probably do that, right? Put the list of what all I use in the notes. That'd be pretty cool. Yeah, anyway, I'm gonna head out of here, run that car on the acrylic, and maybe post up. Did you guys see how that thing works? Oh, I can't use that charger. Anyway, it's just USB. You can actually run it off like a battery power too, because it doesn't actually connect via the USB. It's just using it for 5 volts. So I can run it off of like a little battery pack charger that you could use to charge your phone, and it would run for hours and hours, because it's pinging off the Wi-Fi and then pulling the data of how many subscribers there are and how many views. Yeah, man. All right, you guys. Yeah, I think that's it. Take care. Have a great week. Hit me up if you have any questions about anything CNC related, and take care, you guys.